Are you an electronic hobbyist or a student who would like to learn how to make a simple project? I will show you how you can construct a very simple project. A simple non-programmable flame detector. No need for programming at all. You need a voltage source. You can use a battery or adapter. You have an infrared photodiode, some resistors, an LM358 operational amplifier which will be connected as a voltage comparator. So the work of comparator is to make sure when the voltage to give an output when the voltage at this non-inverting terminal reaches above the voltage of the inverting terminal. The output of that we can power directly to a simple buzzer, and then we will also light an LED so that when it sees a flame it turns on the buzzer and the LED. Before you do the actual construction, if you are new in this area of design and development, it is important first of all you do the simulation. So for this simulation, I used Proteus. With this now we have the battery, we have the LDR. I use the LDR to test the place of infrared photodiode. Then you have a comparator or LM58 or pump acting as a comparator, the LED and the buzzer. So how it works is that when flame is detected, this sensor LDR, or in our case we'll be using the infrared photodiode, it will allow current to flow through when flame is detected, and then a voltage drop will be dropped across this resistor, and it will be fed to the non-inverting terminal of the comparator. So when this voltage of the non-inverting terminal rises above the voltage of the inverting terminal, which is fixed or which is set to be fixed by these two resistors, the comparator will give an output that will power the buzzer and the LED. To start the simulation, you click this button here, and then using this you drag the torch towards the sensor. Then the LED will light and the buzzer will sound. If no flame, the LED and the buzzer are off. If flame is detected, they turn on. The components that you need is a buzzer, a 12 volts piezo buzzer, 5 to 12 volts. Red LED, you can use any other color. 560 ohms resistor, it can be half watts or quarter watts. The same case with two 10 kilo ohms resistor. Then we have one 3.3 kilo ohm resistor. LM358 operational amplifier IC. Then you have our battery or an adapter. It can power from 9 to 12 volts. Infrared photodiode, 8-pin IC socket into where you will plug the operational amplifier IC. Then the strip board, because you are doing soldering. Connecting wires like around 1 meter and solder wire like around 1 meter. This is the assembly diagram. We have the voltage source which is represented by these batteries, 9 to 12 volts battery or adapter. The positive side is connected to this line of the strip board. The negative of the battery is connected to this line of the strip board. Then you have the operational amplifier IC, pin number 8. When you are counting, you count this pin number 1, 2, 3, 4, 5, 6, 7, 8. Pin number 8 is connected to the positive. Then pin number 4 is connected to the negative. Then from there we have a 10 kilo ohm resistor connected from the positive line or positive terminal to pin number 2, and then a 3.3 kilo ohm resistor connected to the ground or negative. Then we also have an infrared photodiode which is connected to the positive line, and the other terminal, this terminal is called the cathode, is connected to the positive line. Then the anode is connected to pin number 3, and then we have a 10k resistor to the ground. Then output of the operation amplifier IC is fed to the buzzer. The output of the buzzer is fed to the ground through this jumper wire. This is a jumper wire which connects the buzzer to the ground. Then we also have another output through this resistor. 560 kilo ohms resistor is connected to this line through which it comes and which is fed to the LED which lights. Also note that below or beneath the IC, cutting is done to protect this connection from these terminals to the other terminals on the other side. We cut this strip board. This is the finished circuit. So we have this line. If you look below, you can see that these are conductors which are running across. So these are copper conductors which are isolated from each other. So the positive is connected to this conductor running along. Then the negative is connected to this other adapter here. Then when you are assembling, you use this IC socket. Then into this IC socket is where we place that IC, and note that this part should go to the upper side like this, like that. You can see that the reason for using an IC socket is that in case this IC gets faulty, it will be very possible to remove it. So you just use a tester and remove that IC. You buy another one and then come and replace. So it is very easy to use an IC socket. So then we have the conductor, the connecting wires, connecting pin number 8 to the positive, then pin number 4 to the negative, 10 kilo ohms resistor connected to pin 2, then 3.3 kilo ohms resistor connected to the ground. Then we have the infrared photodiode connected to the positive one side, and the other terminal connected to pin number 3, then a 10 kilo ohms resistor to the ground. Then another output from pin number 1 feeds the buzzer, positive of the buzzer, then the negative of the buzzer is fed to the ground. Then 560 ohms resistor feeds this LED which lights. So to test, you power and then light a matchstick, then when you bring it close, it sounds an alarm. If you need a screw project or for any other presentation, design, construction and report, let me know.